My name's Dennis Webber. Thanks for this opportunity to talk about the chemical residues in honey. Thanks for Barry for organising it, and Rebecca at Baringa, who suggested I give the talk because we've had many conversations on honey and bees and residues over the last couple of years. I've done a lot of work for Baringa for the last 15 years. I'm a senior scientist with a degree in chemistry, working at the Chemical Residues Laboratory in Brisbane as part of Biosecurity Queensland, which is part of the Department of Primary Industries up here. I have worked in chemical residue analysis for the last 25 years in animal and food products. And antibiotics is my main area that I've worked in, mainly in animal products, but probably the second biggest thing I test is honey. For residues, for MGO, for Manuka honeys, and getting into some sugar analysis from a research sort of point of view of stingless bee honeys. Just acknowledgement of First Nation peoples. I'd like to respectfully acknowledge the traditional owners and custodians of the land on which we meet today. I pay my respects to the elders past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples here today. Looking after bees is what you guys love to do, keeping them healthy, not doing any harm. At the same time, just to let you know, I'm not a beekeeper. I do talk to lots of beekeepers who are asking questions whether the honey is contaminated. Is it Manuka? Is it active? What does active honey mean? What do I need to test for it to send overseas? I listen to try and understand what's happening and trying to help them sort those issues out. Or sometimes I try to find someone else who can help them with their problems. Some of the other things, the downsides that in this job that I do, chemical residues, we actually get bee kills where they've been done maliciously or unintentionally as part of disease investigations. We do have to deal with that. Biosecurity Queensland that I'm part of, look after animal biosecurity and welfare, plant biosecurity and product integrity, invasive plants and animals, and also fire ants, which fortunately you guys don't have down in Melbourne. Chemical Residue Lab comes under product integrity, part of the department, so we can maintain market access, control the use of chemicals. One of the goals of BQ is to mitigate the risks associated with agricultural veterinary chemicals used to promote consumer confidence in Queensland produce, protect the environment, secure ongoing access to key markets. So that's part of the reason Chemical Residue Lab still exists and provide that service. The Chemical Residues Lab, we're only a small group, but most of us have been at the lab at least 20 to 25 years. Antibiotics and pesticides in different products. Honey is one of them. The lab is located just south of Brisbane CBD, on site with Queensland Health Scientific Services, some CSIRO people, QAFI, Queensland Alliance Agriculture, Food and Innovation. They're a University of Queensland group. We help the QAFI researchers with their students, and they use our instruments, and we get involved in their projects and so on and so forth. They're looking at natural toxins or nutritional components of foods. And then the Queensland Health guys are on site with us as well. They do organics, similar sort of pesticide stuff, but mainly in environmental samples. And they have an inorganic chemistry lab doing metals in a variety of things. Together with these groups, we've conducted analysis of honey from around Queensland and Australia for different residues. I'll talk about that further in the presentation. That led to sugar sort of stuff. It led to a Malaysian researcher coming over with a look at stingless bee honeys. And in doing that, we identified that there was a misidentified sugar in stingless bee honey that now we've correctly identified and have published a number of papers that has a number of health benefits. As far as we can tell, the majority of stingless bee honeys around the world. So that's just a little side note. Chemical residues, what are they? Where do they come from? So generally they're from agricultural veterinary compounds that are sprayed on, animals are treated with, plants are treated with in farming and that's practices, but also in people's backyards. It also can be contaminants. So heavy metals and metals are classed as contaminants rather than chemical residues because they're just there. And some of the old style organochlorines like DDT and so on that are persistent in the environment are classed as contaminants. The one thing that maybe not so aware of is the toxins that can be found in honey or the toxins that are found in the environment from in plants or from fungi, they can be classed as a chemical residue. Where do the residues come from? This little diagram gives you an idea. They come from us, but they can also just come from, as in the metals can be in the environment. The bees can pick them up on the flowers, in dirt and dust falling on the hives, many different ways. The main way that residues are found in honey is from treatment of the bees / the hives. You still get contamination in wax and propolis and royal jelly. That will happen, possibly from the same thing, but that will be different due to the different chemical makeup of those compounds. So stuff could come more from what the bees bring in rather than what is put into the bees. Just a quick overview of how we detect and measure chemical residues. The techniques and instrumentation used in analysis of residue depends on what's being targeted. We use a variety of cleanup or extraction methods, but basically we're trying to get the residues away from all the sugars. Probably the simplest way of doing it. That works for most of the chemicals and natural toxins, but not everything. Some compounds that are more water soluble, hanging out with the sugars, and something like that is like glyphosate, like Roundup. We use a chromatography, either liquid chromatography or gas chromatography, to separate the compounds and pretty much use mass spectrometers attached to them to do the detection work. Metals are a little bit different, as in they use different instruments. Honey's digested in acid and then run through inductively coupled plasma, which is plasma flame, which is just a really, really hot flame that ionizes all the metals, and either weigh them on the MS part or use looking at the spectral emissions from those ions they produce. They can identify what's present and also how much. How do we know if a residue is okay if it's found in honey? There's two bodies in Australia that set the residue levels. The first one is the Australian Pesticide and Veterinary Medicines Authority. It's a federal government agency. They do the approvals for the AgVet chemicals to be used. And when they do that, in that approval process, they will set an MRL for those chemicals for whatever commodity it's being used on, whether it's plant or animal. Then the second agency is the Food Standards of Australia and New Zealand. They also have MRLs for the AgVet chemicals, but they're based on what is safe for us to consume. So there's two separate lists for the maximum residue levels. They're very similar, but not in everything. They do work with each other in setting these levels. So if a chemical is, the MRL is what everything is. If it's above it, work out why, and possibly that product can't be sold. If it's below but still seen, that's fine. So that's how it works. So on the left-hand side there, these are the chemicals that can be found in honey. The first three, fluvanillate, amitraz, and fluoromethrin, they're all compounds, and as you can see, a couple of them say temporary. They're all the compounds used in the varroa mite control products that are for synthetic pesticides. Phosphine is used to fumigate, to control wax moth. Fipronil is used in small hive beetle control. Glyphosate is not used on bees. It's just there as a residue because it's used so broadly in the environment in agriculture. And the last one, oxytetracycline, is the only product that is registered to be used on bees, and that's to control European foul brood. So Australia has a residue monitoring program run by the Federal Department of Agriculture. It's called the National Residue Survey. Again, it was set up for the meat industry in the 60s because of pesticides, and over time it's expanded to cover other commodities, so horticultural products, grains, and honey, eggs, seafoods all have programs. The honey program has been operating for over a decade now. It's funded by a levy from honey. The program involves testing Australian honeys for a range of pesticides, veterinary medicines, and environmental contaminants, which ensures Australia's honey industry can meet quality assurance and market access requirements for domestic and international. As you can see there, the last data stuff that I could get on it, there was nothing found above an MRL in the honeys that were tested in 2022-23. These are all the chemicals and elements that are tested for the NRS honey testing program. Antimicrobials or antibiotics. There's the pesticides, is the coverall term for fungicides, herbicides, and insecticides. And then the organochlorines, which are the old school compounds which are now banned for use but are so persistent they are still in the soils all around Australia. And then metals that they've chosen. Antibiotics, this is my area of expertise. It's also the antibiotics residues are the things that causes most residue detections around the world in honey. All the groups shown can be used for treatment of bees and hives. They also used in animals, and those groups are also used in humans. The only two that aren't are the ones at the bottom, nitrofurans. They're banned because they have carcinogenic properties. And one of the phenols, chloramphenicol, is also banned in food-producing animals because it can cause fatalities in humans because it affects bone marrow and causes anemia and death. The other reason it can be a problem with antibiotics is they're overused, which leads to antibiotic resistance, which is also the problem in humans. Why antibiotics used? As we said, foul brood. In Australia, it's only oxytetracycline can be used, but in America and around the world, lincomycin and tylosin and sulfonamides, which is a group of antibiotics, can be used. Nosema can be controlled overseas with Humagillin, but it's not registered in Australia. The other reason you can get residues of that particular antibiotic, streptomycin, is actually used on fruit like apple and pear trees, and it's used in New Zealand to control blight on the trees. So that could be easily picked up by bees and brought back into the hive. But the streptomycin can also be used to control foul brood as well. This is just the list from my lab of all the antibiotics that are covered under those different groups. So we're the NRS contract lab for honey in Australia. We also do pretty much the same list in animals. The only one we don't do is chloramphenicol. It's done by another lab, and they also do the nitrofurans. The MRL for oxytetracycline is 0.3 milligrams per kilogram. Our limit of reporting is 0.01. So we do find stuff in between those two. We do NRS honeys. I also do a number of private clients who are looking for residue testing. And we do every so often find honeys in between those two ranges, which is fine. Is anything ever found? On the left there, we have a table from the NRS for the last 6 years. In 2017, 2018, there was one honey found that had oxytetracycline above the MRL. So that's why the compliance rate is not 100%. Every other year, there has been no detections of pesticides, antibiotics above MRLs, which is good for Australia, shows that we don't have a problem of misuse of antibiotics from the honeys that we do get tested. I found this contamination in honey analysis from the EU Rapid Alert System for Food and Feed, a paper from 2 years ago. Europe's very big on testing for residues. So this shows 2002 to 2022, the detections of antibiotics in honey and royal jelly, but majority would be honey. And these are detections whether they're above MRL or between that limit of reporting and a MRL of detections of antibiotics. So you can see in the early 2000s, it was very prevalent, and then it has slowly dropped off. I don't know how many honeys were tested in total. The paper didn't give me that information. People are changing their behaviours. So this is just part of the table from the most recent data that can be available for NRS. So this is 2022-23. There was one oxytet found, greater than the LOR, but less than the MRL. So we do see them, but it's not a notification. So that's why we still look 100%. The honey's tested in Europe from all that data from those 20 years. So the honey alerts are less than MRL, but greater than LOR detections. We test for all of those compounds except for a couple of them. As you can see, Australia is in that list, and there's a bunch of other countries in that list that have been in that time. There was an Australian royal jelly that was detected with chloramphenicol in 2003, and then there was a bunch of honeys being imported into Australia around that same time that had chloramphenicol detected. They were rejected. And that was around the time there was a severe, I think there was drought, and the honey production in Australia was quite low, and honey was being imported into Australia. And so, yes, there were detections around that time. The ones at the bottom are the similar chemicals and the same chemicals as above, but they were actually above MRLs, high levels, and those honeys would have been rejected at the border in Europe. I'm still testing honeys for chloramphenicol for people sending to Malaysia and other countries. I don't always know where they're going, but I do get asked regularly. I've done, I think, 6 or 7 samples this year already for chloramphenicol, apart from just the general antibiotic screen. Not that I've ever found any, but it's still being looked for. Again, this is why I come back to why I think honey has residues in it, is because of what's being treated to the hive. 80% of all the alerts in Europe for those 20 years were for veterinary medicines. As you can see, there was some small amount of adulteration, fraud, just dirty honey. There was some pesticide residues, but very few. And the last one was just poor paperwork. This is what they found in those 20 years. Chloramphenicol was the main culprit. And then the sulfonamides, even though it doesn't look big, there's 5 of them in that list. They all have the same mode of action. They're going to be used for the same reason. There's 99 of them in total of sulfonamides. They're the ones that have been found. Again, most of them are used to control foul brood. Normally with chloramphenicol, it will work, but it's a banned product. I haven't shown data, but I've got data from Canada, look for, who are also very good at residue programs from 2021, 22. I looked at. They had the same compounds being detected in the honey. Again, I don't know whether they're imported honey or Canadian honey. I don't have that information, but I think majority would be honey being imported into the country. Pesticides. So most of them are insecticides, apart from the herbicides and fungicides. People do get concerned about neonicotinoids in bees. They are mostly banned in Europe now. Fipronil is it's on its own, not in a particular group. It's quite bad for bees. And then we have synthetic pyrethroids, which flumethrin and fluvanilate, which are used in varroa control products. They're what we talk about when we talk about pesticides. What has been found in Australia? Pretty much nothing. They're looking for the organochlorines. They're looking for the fungicides. So when it says here MRL not set, that means anything that's found is a violation. So there has been nothing found. Again, organophosphates and other insecticides, just as a selection of them. Nothing found in Australia. This is from that honey paper. In that 20 years, they found coumaphos, acrylcysteine, and torfluvanilate. Again, all used to control varroa in the hive. And then from Canada, they found amitraz. A quarter of all the honeys had amitraz or its metabolite residues, which is a little bit concerning. They were below their MRL, I believe, but they were detected. The next 2 neonicotinoids, and again, fluvanilate is a varroa control. So you guys are going to have to face varroa and controlling it with the products, and we're going to start seeing residues of those compounds in honey. The last part of the NRS program is metals. This is actually from one of these combined projects between DPI, QAFI, and Queensland Health. The inorganic guys did a whole bunch of analysis on these honeys that were collected from peri-urban, rural areas, urban, and then blended honeys. There's just a quick little graph of all the different elements that we'll look for, and then some graphs of the major components that were found. I'll go through this further down the presentation. Again, this is NRS metals. They look for 4 of them. I don't know why they only look for 4, but that's what they do. There is no limit set because they don't know what is a bad limit. So we have natural toxins. There is plants in Australia that are introduced or native that have compounds in them, pyrrolizine alkaloids. I just call them PAs. It's a lot easier to say. Here, Patterson Coast, well, not that it's in Queensland as much, but down south, it does produce them. We did a whole trial on it. I had a client who was looking for PAs and honey because they needed to send it to Europe. We didn't do it. There were some QAFI guys in my building who had experience with it, looking for implants and problems in the beef industry. We put together this big project. We collected all these honeys, looking at PAs and also metals and pesticides and polycyclic aromatic hydrocarbons. There's 600 of them. Some of them are quite potent carcinogens. They give you chronic liver damage, acute liver damage, affects livestock and humans and wildlife. There's where they found in Australia. This is what they found. Most of the honeys were from in Brisbane, so they are very dominated by the local plants that produce them. FSANZ, the food standards, there is no regulatory level because there's no evidence of harm with normal consumption of honey. They look for them in Europe as well. It's just something that is unknown. I think over time that may change, but at the moment that's where it is. These are probably some of the compounds, and they can identify which plants they came from. We did get honeys from other parts of the country, but not as many. And they did see the presence of these plants due to the compounds being found. The PAHs were included when they did the big survey because we were collecting honeys from the urban areas, off rooftops, restaurants and houses in the inner city, in congested areas where they had beehives. From an environmental point of view, these compounds, the PAHs, are formed by incomplete combustion of fossil fuels. Less than 20% of the honeys had PAHs. Stingless bee honeys had more, but that's possibly due to the fact that you only go to a hive once a year. And none of the PAHs that were detected were carcinogenic or bad. Again, the metals just basically showing that there was no difference between where the honeys were found or from, whether there was the levels of metals. There was no significant levels of heavy metals like lead and such. And the other thing, just they did pesticides. They found one pesticide, pyrethrum, synthetic pyrethroid, that's used on broadacre crops. But that honey was actually a blended of Australian and imported honeys. But that was a really good project. So just a bit of a sell for what we do. Up at the Health and Food Sciences Precinct, I do methylglycol and HMF and Manuka honeys. I do organochlorines and beeswax. I do that because I had a client who had something found in Europe, and then now they screen all their beeswax. And I have found DDT and dieldrin in a few samples, not many, but that doesn't surprise me because it's in the environment and they take forever to break down. I'm currently developing a screen for all the varroa control product and any other pesticides that have an MRL in honey. The Queensland Health guys, they can do food panel testing. They actually do the C3, C4 isotope ratio test for adulteration. They can do the PAs, natural toxins in honeys. They can do the metals in honeys. And the coffee and Queensland Health guys are doing further research into sugars found in the stingless and European bee honeys because the standard methods aren't good enough. And the Queensland Health food scientists are employing some new technologies of using ion chromatography and mass spectrometry and actually identifying a whole bunch more sugars in honeys that have been basically sort of missed because of sensitivity. So I'd just like to thank my colleagues I work with in DPI, in the coffee and Queensland Health, especially the Dr. Natasha Hungerford from coffee. She gave me some of the slides for the metals and the PAs from their papers that she'd done presentations on. All the references where I got my information from, and then the food standards and National Residue Survey, and also just down here, the Varroa program. It has the stuff about all the products that can be used.